Today, I want to talk to you about resilience. Normally we use the word resilience to talk about humans, like humans persevering through famine or war. But in this paper, Regime Shifts, Resilience and Biodiversity in Ecosystem Management, resilience is given a much more specific meaning. For ecologists, resilience is a measure of how effectively an ecosystem can respond to stress. More specifically, resilience is defined as the magnitude of a disturbance that a system can experience before it shifts into a different state. So what do I mean by a different state? Well, take a look at this coral reef. This is a picture of two possible states of a reef. These basins here, they represent the two states. A stable state is a state that the system will return to after some kind of disturbance, like a storm or a disease outbreak. In this state, the reef is dominated by coral. In this state, the reef is dominated by alga. Like I said, these lines here are called basins of attraction. When a perturbation happens, like a storm or a disease outbreak, it can push the system from the bottom of the basin up the hill to the top. But when the perturbation goes away, the system will tend to return back to the center of the basin. So the size of the whole basin is a measure of the resistance of the system. When we disturb an ecosystem by removing systems or polluting, what we're doing is we're changing the basin of attraction. It goes from being deep down here to being shallow. So here's what happened to this reef ecosystem. The reef was originally dominated by corals, and corals compete with alga for sunlight. When the reef had high biodiversity, there were many herbivorous fish that ate the alga, allowing the coral population to flourish. Over the course of several decades, overfishing by humans slowly removed most of the herbivorous fish. But there wasn't a super big noticeable change. The reef still remained coral dominated because as the fish population went down, sea urchin population went up, and the sea urchins kept the algal populations in check, allowing the reef to remain coral dominated. However, although it was still a coral dominated reef, the resilience of that entire reef ecosystem was massively decreased by the loss of the fish. Which is to say that the basin of attraction of the reef went from looking like this to looking like this. The thing is, it's much easier to shift ecosystems into alternate states when they have lower resilience. The new, higher densities of sea urchins made the entire population more susceptible to disease. And when a disease outbreak did occur and the sea urchin population dropped, that shock to a single population was enough to send the entire ecosystem into a different stable state. Which is to say that once the ecosystem was in this state here, it only took a tiny perturbation to send it to this alga-dominated state over here. So what does this mean for the big picture? Well, at the end of the paper, the authors state that the biodiversity insurance metaphor needs to be revived. By biodiversity insurance, they mean that biodiversity can help insulate an ecosystem from stresses like droughts or storms that might overwhelm a less diverse ecosystem. Big droughts and storms might seem incredibly destructive, but in actuality, the damage that they cause is really only a symptom of a much larger problem, the loss of resilience. By preserving biodiversity in the places that we live, we can ensure that when the next natural disaster arrives, it doesn't permanently change the landscape. In other words, biodiversity is essential for resilient ecosystems. This video would not have been possible without this woman. This is Dr. Pryor. She's my ecology teacher, and she introduced me to the paper that I presented, and she gave me her slides. So thank her for this video. And also, you can click here if you want to subscribe and see more videos just like this one. Okay, bye.